In Unit 9, Day 1, we talked about parametric equations. And to introduce the idea of parametric equations, we talked about at a convenience store the sales of sunscreen versus ice cream. And maybe noticing that when no sunscreen is sold, absolutely no sunscreen, there's still some ice cream sold. But then we notice that as more sunscreen sells, it seems like more ice cream is selling too. So then an incorrect assumption here would be that, well, sunscreen is the reason that ice cream is getting sold more, because as sunscreen increases, so does the sale of ice cream. So we have but what we can talk about though is that both of these things are going to sell more when it is hotter outside. So it turns out that both of these are actually dependent variables that depend on a third variable. So we could say like sales of sunscreen are S and sales of ice cream are I, and they both depend on T, where T is temperature. So then the higher the temperature, the more of both of these items that we're going to sell. So it turns out that S and I are both variables, two variables that depend on a third variable T. And we could say that S of T and I of T are a pair of parametric equations. So we then extended this to a point in space, in two-dimensional space, that starts at -1, 2. Okay, at time t equals 0, this is at -1, 2. And as time goes on, this point is just moving off in space. It's moving in a straight line. And what we said was that at after 1 second, this point is at 2, 6. So we can actually write a set of parametric equations where we define the horizontal and vertical position of this point, x and y, as this third variable time changes. So first thing we notice is that in 1 second we go from -1 in the x direction to 2 in the x direction, which is an increase of 3. So x of t started as -1 and then increased by 3 after 1 second. And it turns out it's going to increase by 3 every second. So x of t can be written as -1 plus 3t. And then y of t similarly can be written as 2. And what are we increasing by? We're going from 2 to 6. So it's 2 plus 4t. Right? So basically what we're doing here is we can look at this line and we can notice that it has a rise of 4 and a run of 3 for a slope of 4/3. We would say in our normal notation m equals 4/3. But parametrically what we're doing is we're just splitting that up into two equations where we have our rise here and our run here, and we can see that our rise and run are changing depending on time. So we have x, we have y, we have t. And as time goes on, we're just going to keep following this line. After 3 seconds, or after 2 seconds, let's do x of 2 and y of 2. We would be at -1 plus 6, which is 5, and we'd be at 2 plus 8, which is 10. So that's after another second, we're on this line, we'd be at 5, 10. So we introduced this new notation where we have these weird triangular, like more angled looking brackets, and we have our x of t, y of t. So what this is we're calling this vector q of t. It's supposed to be a t, q of t. And this is actually a bunch of vectors that are starting at the origin and pointing to different spots on our line that is being traced out by our point. So what I mean is that, for example, q0, the vector q0 is going to be written as -1 plus 0, 2 plus 0, right? So what this notation means, and I should use the correct bracket here, what this notation means is that this is the vector that starts at the origin and then points to -1, 2. So that's going to be this vector. Okay, points to -1, 2. And notice that we are going -1 in the x direction and 2 in the y direction. That's our x and that's our y. Okay, and then if we were to do q1 now, vector q1, then we're plugging in 1 for t, and we put that little arrow thing on top of our q, right? So now we're doing -1 plus 3 because t is 1. So we get -1 plus 3 is 2. And then we do 2 plus 4 because, again, t is 1, and that gives us 6. So now we have a new vector that starts at the origin and points at 2, 6. So it's going to be pointing more like that. Okay? And so then we put our point where the vector is pointing, and then our object is going to follow the path that is traced out by the different vectors that are drawn. So this is the path of our object. It's just following where the vectors are pointing. So let me show you a more detailed or a more complete picture on the next page. So if we're looking at the path of our object, our path is traced out by these different vectors that are changing as time goes on, right? As time goes on, these vectors, their horizontal components are increasing by 3, the vertical components are increasing by 4, which is creating this line with the slope of 4 over 3. And we're only showing t equals 0, t equals 1, t equals 2, but obviously there's all these different times. There's like t equals 1, 1.5 in here between 1 and 2, which is going to point exactly at the line. We have t equals 0.5 between 0 and 1, negative 0.5, right? We have all these different vectors. There's infinitely many of them. And when you plug in the t value to qt, it's going to give you a result that perfectly points at the linear path of this object. So the next thing we did is we extended this to 3 space, and we said we had a point at, we said -1, comma 2, comma 2, and then after 1 second it was at 1, 3, -1. So now we want to write x of t, y of t, and z of t to show the horizontal, vertical, and I guess z components of our object as it moves through 3-dimensional space. So the first thing we can always do is write our initial point, our initial x value, our initial y value, and our initial z value. And then we're saying after 1 second, we go from here to here. So we say, well, in the x direction, we're increasing by 2 in 1 second, so that's going to be 2 every second. We're increasing by 1 in the y direction, so just 2 plus t. And then we're actually decreasing by 3 units in the z direction every second. So here's our parameterization. Now, if we want to draw our vector, or write our vector that, or our set of vectors that is going to trace out this line, we say qt. Use this little arrow thing, equals, and I'm going to have to go over here. So first is our x component, so that's -1 plus 2t. Our y component is 2 plus t. And then our z component is 2 minus 3t. So what this is going to do is this is going to create a bunch of vectors in 3 space, and those vectors are going to change as time goes on. But what those vectors are going to do is they're going to, the tip of those vectors is going to trace out the linear path of the object that starts here and then goes through here. There was some other things we did in the lesson, but this is the main thing that you need to get right now, is just the path of a linear of an object moving linearly both in 2-dimensional space and 3-dimensional space. And we got a little bit into what it looks like when an object takes on a curve, but we will hit more of that in the next block period.